So f triple prime of a, x minus a cubed over 3 factorial. Do you recall the equation? So this is the equation for the Taylor polynomial. So if you recall, the special case of the Taylor polynomial is the Maclaurin polynomial, and that's when a is 0. But this first question is an example where it's a Taylor series about x equals 1. So that means this a is 1. So we're going to stick 1s in there when we write this out. Okay, so let's back up the truck and start over again. The function f has a Taylor series about x equals 1 that converges to f of x for all x in the interval of convergence. It is known that f of 1 equals 1. F prime of 1 equals negative 1/2. And the nth derivative of f at x equals 1 is given by this equation. So basically what they're telling you is they've given you this, they've given you this, and if you need to figure out any of the other ones, the general equation for the nth derivative, that's how you interpret that, is given by that equation, and all you have to do is stick in whatever value of n you are on. And notice that it says that this equation for the nth derivative is valid for n greater than or equal to 2. Why is that? Because they already gave you what the value of this is for n equals 1, correct? So they only need to give you this equation for terms 2 and greater. So this says, write the first 4 non-zero terms and the general term of the Taylor series for the function about x equals 1. So that means we're going to take this equation, the first 4 non-zero terms is just what I happen to write out. So we need 1, 2, 3, 4 for part A. So I'm going to write out our equations for what we're given. So we're given f of 1 equals 1. We're also given f prime of 1 equals minus 1/2. We need to calculate some of these other derivatives. So we've got this one. We've got this one. We need to do this one and this one. So let's do that first. So we're going to do f double prime of 1 using this equation is minus 1, and since this is the second power, that means n is 2, so that's squared, and we're going to say 2 minus 1 factorial all over 2 to the second power. So this becomes 1, this becomes 1, so I have 1 over 2 squared is 4. So now I know f double prime of 1 equals 1/4. Now I'm going to figure out f triple prime of 1, again using this equation, minus 1 to the 3, because it's the third derivative, so n equals 3. 3 minus 1 factorial, 2 to the third. So this time, the alternating term gives us a negative. We've got 2 factorial over 8. So this becomes minus 1/4. F triple prime of 1 equals minus 1/4. So we can put together this equation, the first 4 non-zero terms. So let's label that. I expect you all to be able to do this. So this is going to be 1 plus, or you could say minus 1/2. I'm going to write negative 1/2, and this becomes x minus 1 plus the second derivative, 1/4 x minus 1 squared over 2 factorial minus 1/4 x minus 1 cubed over 3 factorial. That gives me exactly 3 terms. Now personally, I would label it P3 of x equals. Sometimes people call it T3 of x, P3 of x, or T3 of x is fine. T3 of x looks too much like text, reminds me of T-Rex, and I don't know, it reminds me of dinosaur. Okay, so now we need to find the general term. And actually this is way easier than you think, because all we really have to do is go back to this general equation and we write the nth term. Well, writing the nth term for this part and this part is easy. You just write x minus a to the nth over n factorial, and then we have an equation for f of n. So we just take this and put it up here. That's going to go right there. So our general term, and I'm going to pull my paper down, is going to go right below this. It's going to be my f of n minus 1 to the n minus 1 factorial all over 2 to the n times the rest of this stuff that we said that we needed, x minus a to the n all over n factorial. Now in this case you can see that these simplify, correct? Because you know the definition of factorial. So reminder, what is n factorial? N factorial is n times n minus 1 times n minus 2 times n minus 3, and you keep going till you get down to 1. Or we can rewrite that as n times n minus 1 factorial. So that means this part down here could be rewritten as n times n minus 1 factorial. And if you do a careful study of numerator and denominator, the reason I did that is so that I could cancel those terms. So this is going to cancel this. So your final full credit answer for the general term would be minus 1 to the n, x minus a to the n, all over 2 to the n, and what is left? Just an n, correct? So that's your final full credit answer for the general term. Back here, I'm going to back up just a little bit. It's probably a good idea that we do some simplifying. So in other words, rewrite this as 1 minus a half times x minus 1. 4 times 2 is 8. So this is going to become 1/8 x minus 1 squared. 3 factorial is 6. So 4 times 6 is 24. So that final one's going to be minus 1 over 24 x minus 1 cubed. So that looks good.
Do we have to simplify it on the exam or
not? I would do it, yes, because all the answers that I see are simplified when I look at the rubrics. So yes, I would think that would be a good idea. So moving on to the next question, the Taylor series for the function f about x equals 1 has a radius of convergence of 2. Find the interval of convergence. Show the work that leads to your answer. Now, I'm going to show you the way we do it, and then I'm going to show you a different way. That's kind of a shortcut, but I like using the way we learned, but really on the exam, this shortcut will work. Okay, so intervals of convergence usually come from what? The ratio test. So I'm going to quickly run the ratio test. Minus 1 to the n plus 1, x minus 1 to the n plus 1, 2 to the n plus 1, n plus 1 squared. Now I'm going to, normally I would write out the step where I divide by a sub n, but I'm just going to go ahead and move to the next step where we